All right, so let's get started. A reminder, I'm sure you're all fully aware that homework 1 is due. But just a reminder that also team formation is due. If you haven't submitted the team formation form, make sure you let me know. Even if you don't have a full team of 4 or 5, let me know what teammates you did agree to work with, who did agree that you're going to be on a team together. Even if it's 2 or 3. If it's 2, there's no guarantee that you're going to be together, because if everybody submits with a team of 2, I have to, actually that would be easy, I just combine the pairs. But there might not be a feasible way for me to combine all the groups. So if I get a whole bunch of 2s and 3s, there's no guarantee, but let me know your intentions. And then if there's a simple, feasible way to combine the groups of 2s and 3s into 4s and 5s, I'm going to do that. Now my mind's going to like a mathematical proof. Is it possible to give me a set that's not possible to do that? I don't know. Maybe. It's not what I'm going to think about right now, though. I guess if there's 6 students not in teams and there's 2 groups of 3, there's my counterexample. All right, and 331 sidetrack. But make sure you fill out that form. If you don't have a team, if you've tried and you just couldn't find a team or whatever, after midnight tonight, I don't know, I'm pretty tired, so I'll probably pass out before midnight tonight. But tomorrow morning, or at least by Monday, I'll form the teams of everybody who didn't fill out the form with 4 or 5, and I'll email you and say, here's your team. I'm just going to choose them randomly. I'm just going to, whoever's not on a team after this deadline, just kind of randomly form your teams just so you can get started on the project. If you're having trouble finding a group or you don't want to find a group, whatever. I'm not going to be picky in this class. This ain't 442 where I am picky about that. I'll email you and let you know who your teammates are. But if there are people you want to work with, make sure you fill out that form. Let me know. If I don't know, there's nothing I can do for you. And with homework 1 due, are there any, did I get any student? I got 3 students in office hours with just simple questions yesterday. So I'm assuming homework 1's going pretty well based on that. But are there any homework 1 questions that I can talk about? I don't think the slides will take up the whole 50 minutes. So I can take like a few homework 1 questions if people have them. Is there something somebody's like really stuck on that's something that would be relevant to the rest of the class as well? Yes?
Just a quick question on like...
Oh, I don't have Discord.
It's not really referring to homework 1, but it's just sending content in general. Just to clarify, like no matter what the type of content is, we just need to convert it to bytes and then add it?
Yes. Okay. Yep. So no matter what content you're sending, the internet speaks bytes, and it only speaks bytes. Well, it speaks bits, speaks high voltage, low voltage, light, no light. That's the only thing the internet speaks. So whenever we send something over that socket, whenever you're calling like send all or transmit, whatever the method name is in your language, whenever you're sending information over that TCP socket, it can only be bytes. That's the only thing it can be. In some languages, you can give that method a string, and internally to the library, it's going to convert it to bytes for you if you give it something that's not bytes. But in the end, it has to be bytes. So you can always send bytes. I think JavaScript, the net library, I think you can give it a string, and it'll convert it to bytes for you. Confirmation. Good. Thank you. But yeah, images, no. So, but you can always convert your string to a buffer. You can do buffer.from on your string and then send it. The only thing you're doing is inside that library where it says, if this is a string, do buffer.from. That's happening somewhere in that library. Possible they're using a different method than buffer.from, but they're converting the string to bytes and encoding it using UTF-8 at some level. You can do that and just give it the bytes directly, and it saves the library a step. So you can only send bytes. Sometimes library helps you, but you can only send bytes over that wire. So if you have something that's not a string, maybe something that library doesn't support, it's 100% on you to convert that to bytes before sending it. But any content at all that you can imagine that can be encoded with bytes, you can send that in your HTTP response. Create a byte array with those bytes and send it. And then through the content type, we're telling the browser how to decode those bytes. So the bytes are just 1s and 0s in groups of 8. And then the content type, the content length says, I'm sending you this many bytes. And content type says, this is what those bytes represent. This is text and use charset UTF-8. This is an image and use the JPEG decoding algorithm. This is a video and it uses the MP4 algorithm, compression algorithm. So that's how we're communicating over the internet. We send bytes and then content length, how many bytes, content type, what do you do with these bytes? Tell the browser what to do with those bytes. And that's going to ring true throughout this entire course. So if that's something that truly benefits you to deeply understand right now, right from homework 1, it'll help you throughout all the homeworks. Because in homework 2, we're starting to receive those bytes, and we're reading the content length and reading the content type to figure out what to do with those things. Well, content type we're going to assume from the path. I assume most of you won't read the content type. But content length, you'll be reading that and then parsing the bytes based on whatever the content type you're expecting from that path. I could talk about bytes forever, but anybody have any other questions, especially pertaining to homework 1? I do have the Discord lecture channel open. We did have some chat this morning. I thought it was 6, like, depending on what we mean by addressable registers in the human brain. But I'm thinking of something else. But like the human brain, we can only think like 6 layers deep is like it's like a hard-coded limit to our brains. If you think of quantifiers like for each, for all, once you go past 6 layers deep, our human brain just can't think of it. I haven't heard of the 16 addressable registers. I don't know if that's just a meme or something. In the world of theory, that's a big thing when we're building circuits and machines, like Turing machines, but beyond that, we call them circuits. And the number of quantifiers, like if you have less than 6 of them, we say that's something that could be potentially computable by a human, which gets into some really interesting, like the cross between CS theory and philosophy. I don't know. That's just what that made me think of. It's really cool stuff. Hey, everybody's good with homework 1? Is everyone just done with homework 1? That'd be fantastic. See quite a bit of nodding, quite a bit of no movement. Hey, I'm feeling great if most of you are just done with that. So let's talk about some more homework 2 content. Oops, I already had that downloaded. And actually, I take that back, the beginning of homework 2 content. We've been using HTML, CSS, JavaScript. We'll use that throughout the course, just here and there. But I don't think I ever asked you to write it explicitly. But the first objective here, writing an HTML template, not just HTML, but an HTML template with a query string. So for this, you have to have a path called images with an S, different from your image path that you built for homework 1. And this can take a plus separated list of images and a name, both as part of a query string. So we can take any number of images from the 8 images of the sample site. You only have to host those sample site images for here. If you want to do more, that's fine, but at least host the sample site images and somebody's name. We want to take those as a query string and serve up a page that says some greeting using this name and also displays all of the images from this list of images in the query string. So what are query strings and how the hell are we going to generate that HTML? Let's talk about it. Query strings and HTML templates. Start with query strings. You've definitely used these throughout your life, but let's talk about what they are. You might not even have noticed that you've ever used these things. But this is a way for a user to send extra information in an HTTP request right in the URL itself. We'll talk about post requests next week where the user can send us tons of information and send us bytes with content length, content type. The query string is kind of a precursor to that. It's a way to send some information in the URL itself. Very limited because it's in the URL itself, but it does allow the user to request via the URL. which does help with certain things like caching. It's if the URL, it's a GET request to a specific URL, then that can be cached, whereas the post request with a certain body of content isn't going to be able to be cached, at least not as easily. But in the, if it's in the URL itself, that URL request can be cached. So that's one big reason why we like query strings. Every time you do a search, at least on Google and DuckDuckGo, I would assume this is true for all browsers. Again, for the caching reason, browsers really want to cache those search results. That's going to be done using a query string. That's one big application. So let's take a look at a few, let's recall, we got to remember what query strings are first. Let's recall the structure of a URL. Quite a bit of this we know already. This whole first part, you're pros at this after homework 1. The protocol, HTTP, pretty much all the time in this class. Colon, slash, the host can be localhost, an IP address, or a domain name, or, other options. Those are the big 3. Colon, the port number. If there's no port number, it's going to default to the port of the protocol. If it's an HTTP request, the default port is 80. If it's an HTTPS request, default port is 443. Or you can specify the port to override that. So in your development, you're overriding that port with whatever port you told Docker to publish your app on. And then the new stuff. Query string and fragment. We talked about these briefly when I first just did a big, quick overview of HTTP. But let's talk about at least query string a lot more in depth. Once there's a question mark in the URL, that's going to specify the start of a query string. And then a hashtag is going to specify, oh, that's my computer beeping. I'm like, who keeps beeping? It's my freaking thing. Then a hashtag, and I can mute that right here. Okay, there we go. And then a hashtag, and then the fragment. So fragment I won't talk much about, so I'll say everything that I want to say right now. Right? I don't have any extra content there. With this hashtag, this fragment is going to specify some extra navigation for this page. So for example, this URL here is going to go directly to the definition section of the URI page on Wikipedia. So it's going to give us some extra navigational content in the URL itself. So if you want to send somebody a link to a specific portion of a page, you'd use the fragment. Yeah.
So is it searching for like the string definition, or is it like how does it know where to go for definition? Like let's say you use definitions.
That would have to be coded by the website itself. So the question is, how would the site know to go to definition? What is definition? Not all pages support fragments, but they support fragments. They'll have their way of doing it. So when you go to Wikipedia and you have the table of contents, when you click a link on the table of contents, it goes to a URL with a fragment for that section of the page, and then you can paste that link, send it to somebody and send a link to that specifically. I have a Wikipedia example here because Wikipedia has really good fragment support on its pages, but it's up to the developers to build that into their sites. But we're here for query strings today, so let's talk about them. So query string is anything after a question mark, which may or may not be present. Not all URLs have question marks. And before the hashtag, which would mark the start of the fragment. So those are 2 very special characters in a URL, question mark and hashtag. Those indicate very significant things. Hashtag is the end of the query string if it exists in the beginning of the fragment. Question mark is beginning of the query string. So whenever we see a question mark in our path, we know that's the start of a query string. And when you're parsing these, go back one slide, when in the request line of your HTTP request, how come I can't highlight this now? In your path, can I do it right here? I just want to highlight stuff. Man, it's giving me a hard time. Anyway, in the path of your request line where you have get and then the path, and then HTTP 1.1. The path there is going to be everything after the port. So from this slash, the path itself, query string, and fragment will all appear in that path on the request line. So where you're just saying if path equals slash hello, now you're going to say if path starts with images slash, then look for the question mark, grab the query string, and then read and parse that query string. But you're going to get that in the path of the request line is where all of this information will be. Everything starting with the path onward of the URL. So the query string, we're going to look for that question mark. And then once we start parsing this, we're going to look for other special characters. Each part of a query string, each piece of information is going to be a key value pair separated by an equal sign. If there are multiple key value pairs in the query string, they're separated by ampersands. I don't have too much to say about that. That's the format. That's how you're going to write your string parsing to be able to get this information out of there. And I'm confident that you can all parse that, that format. Split on, look for the question mark, everything after the question mark. We can assume, since there's no fragments in the homework assignment, you can assume there's no fragment, just take everything after the question mark. Split on ampersands for each of those splits, split on equals, and get the key value pairs that you're looking for. And then for the images, split on plus. Really use that, lean into that split method of strings and get all that information that you want. These query strings can only contain a subset of ASCII characters. Not all ASCII characters are allowed, including white space. Spaces are not allowed here. So when you're parsing your request line, the first thing you're doing is splitting on spaces to get the 3 values. If we allowed spaces in the query string, we'd be in big trouble. Everything would break. The whole internet would just fall apart if somebody started putting spaces in their query strings. Not allowed. We're not gonna let people do that. If you want, go ahead.
Is there any time a URL will have a space, and why are spaces so avoided?
Because you wouldn't be able to parse the request line.
Well, wouldn't space just be like a character?
But it's a special character that we're using to separate the 3 values of the request line. Oh. So since it's already reserved for that purpose, we can't use it for another purpose. Or else it would break all your parsing. Right like this. So if we want something that's not allowed, if we want any UTF-8 characters or any banned ASCII characters, we're going to have to percent encode them. You've probably seen these in URLs all the time. And we mentioned it Friday, was it? We saw that? In one of the lectures last week, we saw a demo where I said, hey, look at that %20 in there. If we want these banned characters, we're going to have to percent encode them. This is a URL encoding format. We're going to have a percent sign followed by 2 bytes of information. 1 byte of information, 2 hex characters to be able to encode that. So if we want a non-ASCII character, we can percent encode it with its UTF-8 encoding with a percent sign leading each byte. For ASCII characters that are banned, like a single space, we're going to percent encode those with %20. Now I'll tell you right off the bat, percent encoding isn't something you have to worry about for the homework. It would just be extra stuff that's not too related to the course content. But I want to make sure everybody knows how you can handle this and what those things in the URL are when you say make a Google search with a space in it. You see that %20 in the URL. That's what's happening. It's being URL encoded with percent encoding. So single space, it's hex 20. So %20 is imprecise. It's 20 in hex is the ASCII, or the ASCII is the ASCII byte. It's ASCII. I don't know. I'm trying to say something more, and there's nothing else to say about it. So white space is usually encoded as %20, or sometimes some sites like to use pluses instead of these percents, depending on, I guess, just how the developer felt, apparently. Sometimes you see pluses, sometimes you see spaces. According to URL encoding, the actual spec, apart from how developers use the technology, use the protocol, Plus is to indicate a key mapping to multiple values. So like if you want to send a list of elements, like for our images, we want to send a list of elements. Here's several elements, all related to the same key. That's what the plus is made for. But some developers say, well, I have this, multiple strings that are separated by spaces. I guess that's multiple values in a data structure, and they'll use pluses. So sometimes you'll see pluses instead of the percent encoding. But that's what the plus is supposed to be for, is multiple values that map to the same key, so we can have these sequential data structures in our query strings. Yeah.
This is about a white space. If we get a white space character as a path, then I don't know.
Well, you won't get a white space character.
If you put a space after the slash, it just takes you to the index. So how would that be called for?
If you're referring to the empty string comment?
Yeah.
So I did delete that right before lecture.
Oh, yeah?
So, yeah, that was an artifact from last semester. Yeah, you don't have to handle the empty string for a 404. Empty string will be just a slash, and that's going to go to your home page. So the slash should go to your home page.
Yeah.
But that was, I used to have the objectives mapped differently across the homeworks, and the home page wasn't until homework 2. So a 404 on a slash should have returned a 404, the way I had the homeworks arranged last semester. And I just forgot to delete that, is all. But I deleted it this morning, right before lecture. So there are certain reserved characters. None of these characters are allowed in your query strings. It's like most of the special characters. These all have a certain meaning. The beginning of a query string, the beginning of a fragment. Colons and slashes. Slashes are how we're differentiating the path, and the colon / after the protocol. These all have strong meaning. Ampersand separating the key value pairs in a query string. Equal separating the key and value. All these have special meaning in URLs. So we can't use any of them. Most of our special characters. It's easier to mention the ones that are actually allowed, the ones that are not reserved. Dashes, dots, underscores, and tildes. And you'll see these in URLs. This is how we like to separate our data. We love our underscores in programming, so if they took that away from us, we'd all be upset. Dashes too, allowed, perfectly allowed. And dots, this is how we're specifying files. If you couldn't use dots, how are you going to request index.html, style.css? That'd be really restrictive if they took that away from us. And tilde, I don't have any commentary on tilde. But you do see that in URLs sometimes, probably just because we're allowed to. So that's query strings. So for objective 1, you get your request, you parse that path. The path is going to contain a query string. Look for the question mark, get all your values, and you have these any number of images, image names, and a name of a user. Now what? Now what do we do? So there are 8 different files in the sample page that I gave you, and it's not objective 4. I saw this right before lecture, and I'm like, well, I'm not at my laptop. I'm not going to fix it right now. It's objective 1 this semester. That was when there were 5 homeworks, so each homework had less content, and you only had 2 weeks. You have 4 homeworks in 3 weeks each, so just the objectives got shuffled around a little bit to give you more time on each homework. I've been favoring larger homeworks where you have more time. It helps you manage your time a bit better, I believe. And then, so there are 8 different images that can be hosted for objective 1, which means there are 256 total possible sets of images that can be requested, all the way from no images at all to all, right? Yeah, no images at all to all 8 images. It would be 256 possible combinations. Then any combination of any of these 8 images. Maybe I want 5 images, 5 specific images. So what are you going to do? Hard code all of those, write 256 different HTML files, and then host a different HTML file for each path that's requested, each query string that's requested. Okay, even if you do that, even if you are crazy enough to do that, and maybe you'll write a script to generate all those for you and not be too crazy, then what happens with the user's name? The user can type any valid name We're going to assume the name doesn't have spaces or any percent encodings. I believe I did put that in the homework doc. If I didn't, remind me so I can add it to it. I'm almost positive it's in there. But no percent encoding, we're going to ignore percent encoding. But any valid string with ASCII characters that are not any of the reserved characters. How the hell are we going to do that? We could have millions of HTML files, 8 for each possible, or 256 for each possible name, and we're still not going to cover, like we can do the common names maybe. If somebody has a common name. We're not going to do any of that. That's just infeasible. It's not going to happen. So instead, we're going to use what's called HTML templates, where we're going to write incomplete HTML files and then complete them when the request is made. So when somebody sends us a request and gives us this data, then we're going to render the HTML, complete it, and then send that completed HTML to the user. So here's an example of a template using the syntax I've come to favor. This is following handlebars syntax. If there's time at the end, I'll hop over to some handlebars documentation and show you an HTML template library. But this is the general idea. You can use any format you want. You have a lot of freedom in how you do your HTML templates. But somehow we want some HTML that's going to be the page that we generate with some placeholders in here that will be filled in later. So now we have 3 placeholders, just something. Handlebars uses this double brace syntax because that's just something you're probably not going to see otherwise. If you see double braces, you know that's part of your HTML template. You're not going to use that in just general HTML, most likely. Unless you're writing a web page that's a tutorial for handlebars, you might have to do some escaping there. But anyway, we have these placeholders, and then when we have to serve a page, we're going to read this HTML file, we're going to read it as a string, we're going to take the data that the user sent us that they want served, and we're going to look for these placeholders, usually with a find and replace. It's the easiest way to do that. Find the placeholder and replace it with the data that the user sent you. So somewhere in your template, you'll have a placeholder for the user's name. You read the user's name from the query string, and then read the HTML from your file, and then replace that placeholder with their actual name. So this is what we call rendering the HTML. You're actually generating the HTML dynamically after the user sends you some data, and then sending them the HTML with their data incorporated into it. That rendered HTML, that's what you're sending to the user. So if we got three pieces of information that we're going to send to the user here, we're going to get their information, replace this HTML, those placeholders in this HTML with their information, whatever they requested, and then ship it to them. Yeah?
Do you ever, for websites, is it typical to use, multiple HTML files, or is it, one big HTML template that has, nested?
It depends on, it's up to the developer, really. It depends on the app. You could have just one HTML file. If you have just one page, if you have a single page app, like a lot of apps these days, you don't navigate around the site at all. There's just one page with everything. So if that's the case, you might just have one HTML file, assuming you're not using some front-end framework. Thank you. Right. But if you have multiple pages, you'll typically have a tree structure of templates. You'll have your base template, which sets up your page with just some information, and then the body is usually just one big placeholder, like stuff goes here. And then you'll have multiple other HTML templates that define each specific page, and they can have their own placeholders. And then to render, you start with the index template, the top level template, and then populate the content based on some sub-templates. And you can even have component templates where you can inject just a little bit of HTML in certain places. You can go pretty deep with this stuff. But there is something, even for Objective 1, we're going to want a little more power than that. We're going to want things like loops. You have multiple images. You don't know how many of them there are. Anywhere from 0, we probably won't test with 0 images. We can say 255 possibilities. Anywhere from 1 to 8 images, and you want to iterate over them and generate the HTML for each one of those images. So adding the image tag is what you would want to do in your homework. Here I'm looping over a data structure and then adding an H6 header with the content of each element of that data structure. So in my code, I'm going to read this HTML template. I have my data structure of elements, and then I'm going to look for the start and ending tag. I'm going to remove those tags after I get everything that's in the middle, and then for each element in my data structure, I'm going to replace that placeholder and add that HTML, H6 content of the data structure, close H6, and add that each time. Just keep concatenating that string each time I find that in my data structure, or for each element of my data structure. Again, the syntax is up to you. This is following handlebar syntax. And you can do the same thing with conditionals. You want to mark the beginning of a conditional, the beginning of an else, the end of the entire conditional. You want to add some else ifs in there. You can generate different content based on what's happening on your site. So for example, if there's a cookie that a user has when you first visit a site, this will be part of homework 4. I push cookies way back in the semester. But if somebody visits the site for the first time, they don't have the cookie set, you want to say welcome to the page. And then if that cookie is set, you want to serve up some different content. Welcome back. There might be different content you want to serve. If somebody's logged in or not logged in, you're going to want to serve different content. Based on that, actually, that probably wouldn't be in a template. That would probably be completely separate templates if you're logged in or not logged in. But you can have a lot of flexibility by adding some syntax into your HTML and then getting that HTML, reading that file, and then modifying and completing the HTML programmatically so you can have dynamic content within your HTML files. And then when the user gets the HTML, they're not even going to know it was generated from a template. They're just going to get raw HTML after the placeholders have been replaced. They won't be exposed to any of this. Tips on how to do that. And I've been talking about the homework throughout. So let's jump over to, well, let's go here first. Let's do a search. Can't even spell. So if we go do a search in whatever search engine and go to the URL, most browsers will hide the query string from you. So if you click on this, you're going to see the query string, which is way too small to see. I'll paste it here just in a convenient spot so I can make it bigger. But DuckDuckGo does use the pluses instead of percent encodings. That's why I mentioned that in the slides, because I know DuckDuckGo does this. And we can see the query that was actually sent. This URL is made for our search. And if we want to change this, maybe we want to say computer engineering means, like all the form is doing, all the search box is doing, oh, I'm not in the URL. All the search box is doing is creating these query strings for you. You can always search with the query string directly and modify your search by building your own query strings, your own URLs. This box right here, all it's doing is taking what you type in there and putting it in the query string, and added a little more information. You can see that it added that I want to make a web search instead of an image search, for example. Oh, I'm not in the, I keep thinking I'm in the address bar. No, I'm on, it should be on images. Well, I forget the exact syntax, but you get the idea. And you can specify the language like we did in the slides. But all that's doing is sending a query string with your specific request. It's a GET request for that information. Your search actually goes in the URL itself. So let's head over to, I want to talk about, oh, we actually have quite a bit of time. we'll probably just end early. Handlebars, HTML will get me there. So here's some example of using that syntax. This is, I don't know, there are a lot of what we call template engines out there. Handlebars is just the one I ended up using. I don't know. For whatever reason, I think they're all so similar anyway. Just pick one, pick your favorite one, and go with it. I landed on this one. So we're going to have those placeholders. This will be part of the HTML template. And then if we give this data, we're going to populate those placeholders with the data that we give it. And one really important reason we want to do this, which I want to make sure I mention, is there like a full example somewhere? No, I'm not going to waste time looking for it, but I did just want to show you the syntax. And then you import handlebars on your back end and then have it render it. So like for your project, if you want to use HTML templates, grab a library like this that handles templates for you in a specific format. You're going to write your HTML templates using their format, and then you're going to render them, calling a render, which I just wanted an example of the render call. Just wanted a full example. But then you render it, so somebody requests a certain path, you're going to say handlebars, render this template with this data, and then you give it a big JSON string in this case. Give it a big JSON string, here's all the data, and then it'll look for the keys in the JSON object, find those placeholders, and then replace them with the values in that JSON object. If there's data structures, it'll loop over, it'll do all that stuff for you. Now, one of the big reasons, aside from flexibility, that we like to use HTML templates is that we always want to keep things as separate as possible if it doesn't make sense for them to be combined. So on the front end, we have HTML, which is only focused on our structure, and then CSS focused on our style, and JavaScript focused on our functionality. So we're keeping the structure of the page different from the style of the page, separate from the functionality of the page. We have all those things in their own separate components. We like to keep them very separate. Another thing we like to keep separate is the data of our page. We like to keep that separate from all those other three components, though JavaScript's going to have a hand in everything at some point. So with HTML templates, with our HTML, when we're writing that, we're only concerned with the structure of our page. We don't even care what's being displayed. If we're going to display a table with all kinds of information and data, the HTML should only be concerned with how to generate one row, like the header row, and then one row of that data. That's the only thing we need to specify in our HTML. And then once we get data to be able to populate, that's when we're going to render that HTML and actually inject that data into the HTML to be able to have it displayed on the page. So it's one more level of separation. We want to keep the structure separate from the data, separate from the style, separate from the functionality. We have all those in our separate components. And sometimes the lines get blurred, especially with modern frameworks and stuff. The framework wants to just take over everything, which, I don't know, for my money, it kind of makes a mess sometimes. But done properly, it can be really good too. So I think that's all I want to say. Anybody have any last questions? Yeah.
Probably good to use a library, but since it's a string, we don't need to use a library, right? Since it's our own, we can do our own syntax.
I do have to clarify this. For the library, I'm showing you the library for your project. You can't use this library on your homework. But when you, that's very important that I mention that. I'm showing you this library, like you can. No. I should just get this right off the screen. No, you have to do your templating for the homework. But I'm showing you when you do go to your project. Yeah, I forgot to mention that. When you go to your project and you're working on your project, pull in a library, write a report for that library, show how that library is generating, rendering those templates and stuff. For your homework, you have to do that from scratch. I want you to have hands-on practice rendering templates instead of just pulling a library, with, along with the spirit of lecture. If I show you something in lecture, with the spirit of the homeworks, if I show you something in lecture and how to do it, you have to do it on your homework. Why else would I show you how templates work if I'm just like, oh yeah, pull in handlebars? There'd be no point in me having these slides. Yeah.
Do we have to use templates, or can we use like classes in HTML, grabbing JavaScript?
And render it front end? If you want to render your content front end, you can. I was going to mention that. I don't really want to convolute things a bit. If you want to do that, go for it. So there are two options here, two big options of rendering I will talk about just briefly. Rendering your HTML server side or rendering your HTML client side. So you can render your HTML client side in JavaScript, and then your server is just an API that serves up raw, usually JSON data, sends the data to the front end, and then the front end generates the HTML. If you want to do that for your homework, you can. I think that's a little trickier to do, which is why I introduced you to this idea with HTML templates. But if you want to do that, go for it. All right, I'm done. Take care, everybody. Have a great weekend. See you Monday.